ax cubed plus bx squared minus 5x minus 4, where a and b are unspecified constants. Suppose the point 1, negative 1, 2 is a point of local maximum. Find a and b. Ooh. This is not exactly like something we've done before, but it's definitely something you can do. So I'll give you a few minutes to work on it yourself. You don't necessarily have to solve the problem, but think about how you would set up the problem, right? Think about what it means. First of all, I'm giving you a point on the curve. Right, so negative 1, 2 is on this curve. That's actually, you can already kind of set up an equation for that. And I'm telling you it's a point of local maximum. Does that tell you anything? Right, think about what does it mean? If you have a local maximum at x equals negative 1, what does that mean? What can you say about this function at negative 1? Okay, so take a few minutes. At least try to think about how you would set up to solve the equation, or solve the problem rather. If you can get a and b, that's even better. Okay, so what did we think? How did you start setting up this problem, even if you didn't finish it? Okay, so Miriam says take the derivatives. Hirsch says I set the derivative equal to 0. Simran says use the fact that the derivative is 0 when x equals -1 and the point given to set up a system. Okay, good. Right, so we're given some piece of information. First of all, the point obviously lies on the curve, right? -1, 2 lies on the curve, right? Since -1, 2 lies on the curve, that means f of -1 equals 2, right? Obviously. And like Simran said, if this point is also a point of local maximum, that means the derivative is 0 when x equals -1, right? So since the point is a local max, we also have that f prime of -1 equals 0. So everyone should understand that that's what we're doing here, right? We have essentially two equations that we're solving for a and b. One second. All right, hello, I'm back. All right. All right, so let's set up this system of equations. Did anyone get 7 and 8? Actually, that's the correct answer. I forget which is which, but yeah, we get 7 and 8. Okay, so let's set up these two equations. So f of -1 equals 2. This gives us the equation -a plus b plus 5 minus 4 equals 2. Or in other words, -a plus b equals 1. And f prime of -1, so I take the derivative of f and I substitute -1, right? So I end up with 3a minus 2b minus 5 equals 0. Right, and again, how did I get that in case anyone asks? Right, I take the derivative of my function, 3ax squared plus 2bx minus 5, and I substitute in x equals -1. That's it. And so now we have a simultaneous system of equations, right? We have two equations, two unknowns, and so we can solve this however we want. So I think the easiest thing to do, honestly, is, so first we'll move the 5 over. I think the easiest thing to do is multiply maybe the first equation by 2 and then add them. So if I multiply the first equation by 2, I get -2a plus 2b equals 1. And then if I add the two equations, I get a plus 0 equals, and that should have been, sorry, should have been a 2, not a 1. I get a plus 0 equals 7. So you immediately get that a equals 7 just by doing elimination. And then from that, you get the b, right? Because from the first equation, we get that b equals a plus 1. So we get that b equals 8. Okay, any questions about this problem, right? The algebra should be pretty simple. The algebra isn't really too bad. It's mostly understanding setting up this system of equations, right? Where do I get the 2 from up top? We multiplied the equation by 2. So we get negative 2a plus 2b equals 2. So questions about setting up this problem.